All right. Good afternoon, everybody, and welcome to SETI Live. My name is Bill Diamond. I'm the CEO of the SETI Institute, and I am live. I can tell because this feels live here in Mountain View, California at our headquarters. And I'm joined today by a NASA heliophysicist and senior scientist and longtime friend and colleague and collaborator of the SETI Institute, Dr. Lika Guhathkurta, who is actually right now live also in Western Australia. And she's there to witness the upcoming total eclipse of the sun. And so we're going to be talking to Lika about that. So good afternoon from the SETI Institute. Good morning Wednesday if you're in Western Australia like Lika. Good evening if you're on the Eastern United States, and good night to all of you if you're in Europe or elsewhere. But we do hope actually you'll use the comments to let us know where you're watching from, as you see right there at the bottom. So hi, Lika, how are you doing there in Australia?
The excitement is certainly building. I mean, getting to this place is not an easy task. It
Right.
is sort of this tippy top of the western edge of Exmouth. This is, I think, probably the only land almost where the eclipse is visible from. So everybody is descending upon this small little fishing village almost. I don't know, someone told me 30,000 people. Um,
Are
Even the
coming in.
birds are excited.
Yes.
I
Yeah,
think they know something is coming.
I remember when we were talking about this when we were together at that last eclipse in Antarctica, and we're talking about the Australian eclipse and how it was just going to skim one tiny piece of land. Others are going to
Literally.
try and see it from the ocean, but I think it's fair to say, even better than I, that witnessing a total eclipse of the sun in person and being there for it is truly an extraordinary and often a life-changing experience, right?
Yes, I call it a transformative moment for a human being,
Yes.
to see a celestial display of this magnitude. People don't actually always believe you when you tell them because we are so used to looking at the sun, we are used to looking at partial eclipses. But the difference between a total solar eclipse and even a 99.9% solar eclipse is just
Right.
night and day.
Oh, yes. Yeah, absolutely. Well, in fact, there may be people watching today who've also been fortunate enough to observe or witness a total eclipse of the sun in person. So if you have, put that in the comments as well and let us know where and when you've seen a total eclipse of the sun. When we tried to observe live the total eclipse of the sun in Antarctica, it was very low on the horizon, very early in the morning, cold, gray morning on the ship's deck, and the cloud cover just never lit up. But the lights did go out, and it was still quite an extraordinary experience for those moments on the ship, Lika, if you remember.
Actually, if I may share that, because I have this is my 12th or 13th, I forget, can't keep track. But one of those numbers that I am actually present at the site of a total solar eclipse, and I have missed four of those because of cloud cover. But what was extraordinary about Antarctica cloud cover is we are deep in the belly of the Southern Ocean, which is violent to begin with.
Right.
And because it was stormy and cloudy, it had an unusual amount of turbulence. And so the sky was absolutely gray.
Yes.
But when the totality happened, the darkness, the moon's shadow traveled so fast that that was pretty incredible.
It
That
was.
darkness you
Mhm.
cannot capture. That
No,
is not the darkness of sunset or anything. It was pretty ominous.
it was pretty ominous. And I
Something
remember thinking at the
something
time,
different.
if you're a primitive historical peoples and you're observing a total eclipse, even if the observed event is startling, frightening, or whatever, if you see the moon's disk pass in front of the sun, at least you know what's going on. On a cloudy day, it's just lights out and you have no idea what happened, and it must be an extraordinary experience when you're not expecting it. But Yes, it was really quite amazing and still impressive, even though we couldn't see it. But it sounds like, from what you've said, the weather forecast for you for what will be tomorrow for you is looking quite promising in Australia.
It is. It's been cleared. Well, there are always, in the morning, kind of low hanging cloud as I look out of the window from the apartment that we are in. But this eclipse is happening close to midday, around 11:30 a.m. So that's fairly high up.
Yeah.
Everything is kind of aligning to at least give us that. Goosebump moment already that it's going to go all well. And the kite, we'll talk about it.
We'll talk about the
That is the big thrill. That's
Yes.
We'll see. But I think it's going to be a spectacular event.
It sounds like it. I'm jealous. I wish I was there. I'm going to try and share my screen so that we can show people exactly where this event is taking place. And hopefully this will work. So are you able to see my screen now? I don't know if Lika or the audience can see it, but I'm going to assume you are able to see it, in which case you should see this map of Australia where my cursor is at the moment. Let's scroll down again. Here we are. And the red line is the path of totality for the eclipse. And you can see here at 3:30 Universal Time, it just brushes this little strip and peninsula of land on the northwest coast of Australia above Perth. And that's where Lika is as we speak. So that's where totality will be. Of course, if you're on a ship, either north or south of northeast or southwest of that point, you might, and you're in the path of totality, you'll also be able to see it if the weather is clear. Going to scroll down here. This is a more close-up view of the path of totality. So you can see this little bit of land, and Exmouth is where Lika is on this tiny little peninsula. And you can see the blue line is the center line of the path of totality. And then there's this sort of darker shadow on either side of that, bounded by the red lines. And that is the overall path of totality that will be witnessed by people who are on that peninsula or ships in the path. So just for context, that's where this whole event is taking place. So very cool. And again, that's where Lika is right now. So
if you bring that picture back, I want to give you.
Oh, okay. Let me do that.
Factoids about this eclipse,
Okay.
that makes it kind of a very interesting eclipse from the ordinary total solar eclipses. So this is actually a hybrid solar eclipse. A hybrid total solar eclipse is one in which part of the path sees annular eclipse. It's basically, moon shadow, Earth's curvature, all of that playing the celestial mechanic tricks. And then there is a path where it becomes totality. So we are in the path of totality. It's sort of the middle band. So the eclipse is basically, the shadow is moving from Antarctica all the way to Marshall Island on your screen, going from the bottom left to the top right.
Mm-hmm.
And the very edges, basically towards Antarctica and towards Marshall Island, people will actually see an annular eclipse, which is sort of the ring of fire that in America we are going to witness in October of this year.
Yeah, absolutely.
So this hybrid eclipse actually doesn't happen very often. So the special conditions have to be met for it to happen. So that's kind of pretty cool.
That's very cool. Thank you for sharing that. So behind you on your screen is this amazing corona. I call it your personal aura, but it's actually corona visible from an eclipse, a spectacular photograph taken from a previous total eclipse of the sun. Tell us a little bit about the corona and about the science that is done and why eclipses, total eclipses, are of interest to heliophysicists and solar scientists, and what kind of knowledge we're trying to gain from them.
So thank you for seeing the eclipse behind me. I think I'm trying to match the eclipse because that's where we go, eventually. So my hair has turned into that pearly white eclipse color. Actually, the eclipse is so phenomenal, we can't reproduce this light in lab. It is the free electron scattering solar radiation that gives this luminous pearly halo look. And the structures that you are seeing, kind of around me, can't keep track of, right and left, but on this side, that's the coronal streamer. On this side, these are rays. The shape of the corona is basically sculpted by the electrons, free scattering of the electrons that we see actually in visible light, and the magnetic field. So why is it not like a big puffy white everywhere? Because the magnetic field is actually controlling kind of regions where the density of electrons is higher or lower or freely escaping into solar wind and not trapped. And so the scattering and the visible light then gives us a really good indication of the strength of density, the structure of the magnetic field. That's at the very basic level, what we see with the visible light in the corona.
Yeah.
Now, why do we, NASA has lots of satellites, right? Looking at the sun, looking at the corona. So why do we still invest in actually taking measurements from the ground, from the ocean, or this time perhaps maybe even from a kite? So the reason being that when we kind of artificially occult the sun, and let me kind of describe what occultation mean. If you put your thumb in front of your eye and you can close your one eye and you can block many things, you can block the sun, right? This is kind of providing that occulting disk to block something. So we put occulting disks on our telescope essentially to block the brightness of the sun so that we can actually see the corona. And we have many telescopes doing that, like Soho Lasco, for example. On stereo, we have many coronagraphs. What an eclipse provides is, so when we put occulting disk, what happens, there are certain limitations. We can't get very close to the sun, at least not in visible light, because the occulting disk has scattering issues, diffraction issues, and so that prevents us from going to the very edge of the innermost part of the outer solar atmosphere, which is the corona, which is where really everything is happening. So if we want to connect to what's happening inside the sun that comes out through the outermost atmosphere, the corona, through the inner edge of the corona, and then becomes the solar wind that dominates the entire heliosphere, literally, then we really have to understand how these particles are transported, how they are generated. And in the corona, it's the transport that becomes very important, from being trapped in magnetic field to kind of getting out through open magnetic field and then going into the interstellar medium boundary, basically. So eclipses give us that opportunity to go very close to the sun, because there is no better occulter than the moon. There is no diffraction. So if the moon covers the sun, moon shadow, then we have like a glorious observation taking possibility, and we try to look at that region with spectroscopy, with high resolution new instrumentations, things that we cannot do any other way. We also kind of test new instruments that can go on a future spacecraft, for example.
Yeah.
So this inner region is sort of the seat that controls and governs kind of what happens, as corona becomes solar wind.
And
And so these observations are critical, even if it is for 58 seconds.
mhm. And one of the mysteries I think we're trying to unravel is why the temperature at the corona is so high compared to the surface of the sun. And this is, I guess, one of the um, points of observation and spectral measurements and so forth, is try to understand the physics that's going on there that would explain why you have this extraordinarily high temperature region as compared to, say, the surface of the sun in the corona.
Yeah, absolutely. It defies the second law of thermodynamics, right? Which says that if you're close to a source of heat, as you move away from that, the temperature should drop. So it's the exact opposite for the sun, right? In the corona. So what happens from a 6,000 degrees Celsius photosphere? How do we get to a 2 million degree corona? Well, clearly there is additional kind of momentum, energy being dumped into it. And there are various mechanisms for that, right? And that's the reason we are we have the mission called Parker Solar Probe, to which
Right.
I devoted, more than half of my career, because all the observations we have of the sun are with telescopes. It's
Yes.
remote sensing, it's integrated light. So we are always having to deconvolve with models. We can't ever be sure whether, what we are deconvolving happened close to the sun, in the
Mhm.
middle, or very close to Earth. We don't know, because it's a line of sight integral. With Parker Solar Probe, now we are going to next, in 2024, we are going to reach our perihelion and get to within 10 solar radii of the sun. So basically, in this environment of the eclipse, and Parker Solar Probe is actually measuring the particles, the density, the magnetic field in situ, meaning locally in the environment where the spacecraft is. And so then that's our ground truth.
Sure.
But Parker Solar Probe is giving us some other visuals and
Mhm.
tantalizing evidence of how particles, waves, magnetic field are interconnected from the very inner edge of the corona into the middle corona. And so this is probably going to rewrite heliophysics. We are just exploring, taking data. We have some amazing results already, but there's so much more to come.
Oh,
And
absolutely.
so this coronal heating mechanism is something that we try to attack with basically everything we do in the corona. And it's an iterative progression, kind of adding to that body of knowledge.
Yeah, absolutely. Well, I'm going to dig into with you some of the science that's going to be done and how it's going to be done for the upcoming eclipse. But a couple of interesting points in the meantime. The first is that we're now entering a period of solar maxima, as we call it, of maximum activity on the sun's surface. More sunspots, more flares, more greater intensity and I guess spectacular aurora phenomena that would be observed in our atmospheres. So tell us a little bit about that cycle, the length of that cycle of solar maxima and minima, and the extent to which a solar maxima gives us a different experience or a different set of observations on an eclipse compared to an eclipse that might happen at a solar minimum.
Thank you for asking that question. It's actually, the change is quite phenomenal. So the eclipse that you're seeing behind me is actually from the 2017 eclipse. And we might want to ask our audience how many people actually observed the 2017 eclipse.
Mhm.
That was visible from coast to coast in America. And
Amazing. Yeah.
another great one is coming. 8th of April 2024 that, people need to be prepared for.
Mhm.
But remind me of the question
So,
again.
what the difference between what's observed,
Yes, so the solar cycle
maximum, yeah,
variation.
and solar minimum.
Right. And so the solar cycle is essentially, kind of giving us a sense of the solar magnetic field activity. And the solar magnetic field activity for us, ordinary lay people, sort of manifests as sunspots, these dark regions on the sun, which are actually much hotter, but it's dark because the magnetic field is so strong it inhibits heat conduction. Isn't that kind of interesting? So the more spots you have on the sun kind of shows that greater is the solar activity. And so this cycle of sunspot activity that we have termed it is about 11 to 12 years long, and it goes through a phase of solar minimum when all sunspots disappear. Basically, not the magnetic field. Deep down, magnetic field never goes away.
Sure.
But the sun manifestation of sunspots disappears, and that's an indication that we have arrived at the solar minimum. And then gradually it will ascend to a peak and then descend and go back to the next sunspot cycle. So we are at the threshold of solar cycle 25, and this is the ascending phase. And these ascending and descending phases are pretty rapid, of the order of 2 years, and it can be even sharper than that. And we are always trying to kind of do guesstimate, essentially, when is that solar max going to happen. And that answer is sometime, perhaps in fall of 2025. But what we are seeing right now in the ascending phase is that the sun has been much more active than in the previous solar cycle. And what we are going to see as a consequence of that during in the eclipse of the sun during this phase is that it is no longer going to look elongated structures. That is a solar minimum kind of corona in 2017.
Yeah.
This eclipse is going to be more spherically symmetric, where you'll have streamers at all different latitudes. And if you are lucky, because I have seen this, you can even see, during the eclipse, post-flare loops. If there's a flare, the solar maximum sort of leads to really a lot of activity, seething, bubbling of the magnetic field. Things are happening non-stop. And sometimes we can catch that with our unaided eyes during a total solar eclipse. So, people, if you are here in Australia in the path of totality, forget taking pictures. There are photographers and professionals who will be doing that for you, but just stare at the sun and see what you can, because it's only 58 seconds to a minute long here.
Don't stare at it before or after, but during.
No, but you can stare only with protective glasses. Okay, so I have to give this message wearing my NASA hat, that is the most important thing we like to and want to communicate. Do not ever look at the sun outside of a total solar eclipse without appropriate filtered glasses, or any kind of solar filter that will protect your eyes. It is not only harmful, it can be injurious.
Yeah, absolutely. Well, thank you for that. The other point, and then we're going to talk about the experiments, is just the extraordinary coincidence we have on our planet, where from our perspective, the moon in our sky is precisely the same diameter as the sun, which is 93 million miles away, and the moon is 250,000 miles. So it's an extraordinary coincidence, though the moon's orbit is slowly moving further and further away from Earth. So this perfect alignment will at some point no longer be as perfect. But I think, if I'm not mistaken, this is the only place in our solar system, at least, where if you were on the surface of a planet with a moon, the moon and the sun's solid angle would be exactly the same.
It's,
if I'm
I
correct.
know we call it a coincidence,
Yeah.
but sometimes, why
Yeah.
you ask
Why?
the
Right.
question. I mean, it is absolutely mind-boggling. Like the sun is like something like 400 times wider than the moon, but it is also a little more than 400 times further from
Hmm.
Earth, and that's what happens, right? It's the casting of shadow and any little fluctuation in that, and that's why we get annular eclipses, hybrid. Total solar eclipse has to be that precise
Perfect alignment.
alignment, so that the sun and moon are the exact same size, basically. And that's why I was telling you this hybrid eclipse is kind of really interesting, because part of the path, it is not that exact dimension.
Yeah.
And that's why you see the annular eclipse. And you're absolutely right. As we are finding out from other planetary systems with moons, they do not seem to be this phenomenon of completely obscuring the solar disk is not at all ubiquitous in the
Yeah.
universe like many other things. So it along with the corona, when you look at it, it fills you with awe.
It
That's
does.
what I mean. I mean, there's coincidence, there's spiritualism, there's just so many things that you can't explain. It just happens to be. We are
Yeah.
the luckiest creatures, right? But I think perhaps the most important of all is that this planet is the only planet we know so far that possesses the life forms, basically, right? Capable of witnessing the
No,
majesty of this celestial grandeur.
that is
I
true.
mean, who else?
That's true. Well, and in fact, we maybe we can talk about this a little bit later as well. But other species that we share our planet with do react and respond during a total eclipse in interesting ways. But on to the science. When we were on the ship in Antarctica, the team from University of Hawaii had their spectrometers and cameras and systems set up, all on these sophisticated gimbaled mounts, so that we could compensate, the instruments could compensate for the ship's motions and hope to make observations and measurements during the eclipse. This time, you mentioned a kite. So the team this time is not having instruments, or maybe they are also having instruments on the ground, but they're planning to fly some instruments on a kite. And of course, I think when most of us envision a kite, we're thinking of that diamond-shaped or Batman-shaped thing attached to a string that we're holding at the beach and letting it flap around in the sky. This is obviously a different class of kite that's bringing these instruments up, and I think you have a video of sort of some testing of earlier flights of this kite that you could share with us and explain a little bit about what's happening with
I
kite.
will. So if you can bring the video out, but first let me tell you sort of the connection to the Antarctica eclipse expedition and the kite experiment. So one of the team members during that eclipse expedition, because we were clouded out and everybody is always so frustrated, raised the question, well, why can't we fly a spectrometer or an instrument on a kite? Then we can perhaps get over the cloud bank
Mhm.
and see the total solar eclipse or observe the solar eclipse with instruments. So, first of all, I want to say basically, it's thought generates action. That was the thought. And everything from there led to where we are. So I also run this RNA program called HITS, Heliophysics Innovation in Technology and Science. And so this proposal came to that bucket where we are looking for innovative ways of doing anything heliophysics related. It got funded. They are here. They are actually going to fly a kite. Just think about that. So let's bring the movie and we can talk about this some more. So this is a test flight that is being demonstrated here, and you can see the kite flying. It's a box shape. It's called a box shape Cody kite. It's got a wingspan that's something like 21 meters.
21
It's
meters.
going to actually, yes, yes.
Wow.
Ain't no ordinary kite.
That's a big
and
kite.
and it's going to, yes, it's going to carry for this experiment spectrometer between 15 and 20 kilogram. So in this particular test flight, they are just carrying a mass bottle that we do sometimes even for NASA if we cannot kind of deliver an instrument to space, just to keep everything going, right? So you have all the balances taking place. This is absolutely extraordinary. The Australian, government, and it has, of course, many branches just like ours. And this particular one, the beach area where we are going to fly this kite from, is associated with the Australian Department of Defense. And so we are going to where the wind speed is high enough. So it's kind of about an hour away from where we are. That's where we are going to fly the kite from. You don't have my other colleagues here on this SETI Live because they are out there kind of going to test out the conditions and all that for tomorrow.
Yeah.
And so the kite experiment right now, the team is doing lots of different experiments from the ground. And there are some links that you probably can see on the chat. For example, the Twitter link from Channel 9 in Australia, who came and interviewed the whole group yesterday. And you will see the layout of all different kinds of experiments that taking place from the ground, which is the bread and butter of the science, which is probing deeper and deeper into kind of the elemental composition of the solar wind in the inner corona as they come out. The temperature, density, diagnostics, looking for prominences and filament eruptions and capturing them in the solar wind and connecting that. And with Parker Solar Probe, because this is Solar Max, because there's lots of stuff going on, we think there's going to be some amazing science coming from all around, all the science observations that are taking place. And the kite has one of the spectrometers, a compact spectrometer that has been designed for this particular occasion. And the biggest thing is, can we fly the kite? And to do that, we have to have wind conditions. It's not cloud anymore,
Right.
but we need wind. So it's never easy. You can't really predict everything. But if it is successful, and even if it is not, it's already a demonstration of a platform.
Sure.
Right.
Yeah.
And so it's just for heliophysics. Why did HITS support this? Because if we have sort of a kite-borne platform, then we can start observing not just the sun, but the near environment of Earth. So, there's region of space that we call ignorosphere, where suborbital rockets can't go, and where satellites don't fly. And it's a very important region of ionosphere, thermosphere, magnetosphere, the geospace environment, which is part of heliophysics. We could be measuring kind of those areas. We could be looking at auroras. I mean, once you have opened up a platform, how the scientific community is. They are going to think of a million ways to utilize that platform and give us science that we wouldn't have had
otherwise. Yeah, no, it's brilliant. And I gather, based on what I saw in the video, then that the instrument payload will be quite a distance down from the kite itself. It's sort of partway
correct,
up.
and it's hanging.
Yeah,
Right.
hanging. Interesting.
And this particular height, so even the height is controlled by the wind, but also by government, different areas. So I think we are allowed to go at a certain height only after a certain time.
Oh, interesting.
That's how restricted the air spaces can be. So I think this particular kite is attempting to reach 3,500 feet.
3,500.
Like about a kilometer. Yeah.
Yeah. That's fantastic.
It's just cool.
That's amazing. And, again, 20 meters. So that's like 60 feet for those on the English system. And I mean, that's a very big claim.
That's what I think. I think it is, yeah.
It sounds about right. I mean, to carry an
Yeah,
instrument
yeah,
payload, it has to be quite sizable.
yeah.
So that's probably correct. Well, that's interesting.
I haven't seen the thing yet because they have taken it to the beach,
Okay.
and you don't want to carry it back and forth. So
Yeah.
it's actually in a secure place. And
They're testing it now. That's great.
yes.
Well, somebody put a note here or a question about, is it true that you can poke a pinhole in a piece of paper or cardboard and safely look through that? And the answer is no. What you can do with a pinhole is make what's some people call a pinhole camera. So if you take and make a pinhole in a piece of paper, thick piece of paper or cardboard, then what you do is let the sunlight shine through that pinhole and project it onto a second piece of paper behind it. So that the pinhole would be on a surface like this, and then below that, this pinhole is between another piece of paper or flat object and the sun. And essentially, you're creating a lens with that pinhole that can then image the sun onto that second surface. And you can do that during the run up to the eclipse, so you can actually see the moon's shadow move across the sun. And then when you get to totality, you can, with your naked eyes, of course, experience that. But as soon as that's passed, you need to go back and you can use the pinhole, and it's really quite fun. On the 2017
Pinhole is extraordinary. I
really
mean, you can hold your hands like this and project the crescents.
series
Okay,
of, yes,
if
yeah,
you have leafy trees, you're going to see the crescent, millions of crescents all over.
yeah.
But I have to get up from here in order to bring that. So I'm the program scientist on a new mission which hasn't launched yet, called Punch, which is actually kind of polarimetric observations of the corona out at a larger distance, not the inner corona. And they have developed some outreach material, really kind of bringing to common people, to students, what exactly does a pinhole projection do.
Mm-hmm.
So they have these three shapes, triangle, square, and circle.
Mm-hmm.
And depending on the surface, how far that card is from the surface, your projection will be identical to the shapes that you have, versus as you move further away, it becomes circular. And there is a lot of science in it that can be taught as to what's exactly happening. You
And
don't
why
have to do lens and optics,
Yeah.
but I will put that link, for you in this web chat
Mm-hmm.
later.
Yeah, we can share that link if you provide that. But that's great. I remember for the 2017 eclipse, I was in Idaho, and one of our artists in residence was with us, and she was creating tiny little holes in the shape of hearts, and putting lots of them on a piece of paper, and then making these absolutely beautiful projections as the eclipse progressed, and it was extraordinary. So by all means, play with different shapes, different size holes, but always let the sunlight pass through those holes onto another surface. Do not look through those holes.
Do not look without wearing appropriate glasses
Never.
the eclipse.
Yeah, absolutely. So that's wonderful. Well, listen, I think we've chewed up all our time here, but it sounds as though as well we ought to have another conversation soon and get an update on the Parker Solar Probe mission, which you and I both watched the launch of, and which, as you mentioned, you've spent so much of your career developing and preparing for. So that sounds like a good follow-up to this eclipse story. And meanwhile, have an amazing experience tomorrow. I wish I could see it, but you'll, of course, send us, pictures and videos. And to your point, the pros will, of course, get fantastic images and video footage of it for us. We can share some of those with our audience as well. But it's great that you got up early and joined us there in Western Australia. Have an amazing time tomorrow, and we'll look forward to chatting again after this is over.
Thank you very much to the listeners. please keep looking at this particular link, because we will add some other links as we discuss, so you can go back and learn a little bit more.
Yes,
Thank you
yes,
so much.
you bet. We'll use our social media platforms to share all those links, and there'll be lots of good and exciting things to come. So thank you, everybody, for joining us today. Thanks for the SETI team, Beth and Lee and Rebecca, for bringing this to us. And Lika, we'll talk again soon. Everybody stay safe and take care. And if you are in Australia, again, don't stare at the sun unless you've got the proper gear on. Take care, everyone. Bye-bye.
Bye-bye. Thank you.